It was a hard childhood, man. I still have trauma deep down. And that's why when you push on your cells, they're squishy. He's just special. He's just a special little man. I may lose some subscribers over this. So be it. Redeem Academy. Yo, what is up, Science Squirrels? Johnny here with Redeem Academy. I'm here to help you get the most out of your education while giving God all the glory he deserves. We've made it to lesson 6 of our cells unit. Today is all about the cell membrane. I'm going to be telling you about 3 things today. What molecules make up a cell membrane, how those molecules give the cell membrane its abilities, and the meaning of the word semi-permeable. While I'm doing that, I'm gonna give you a couple extra nuggets along the way. I'll be telling you a little bit about the best and most expensive trip of my life, and I will let you know who the greatest soccer player of all time is, the GOAT. Big question today, God designed cell membranes to keep out danger. How is this like the way your parents set boundaries to protect you? Ooh, this might be hard to hear. All right, let's get into it.
In this video, we will be discussing the structure of the cell membrane. When scientists looked at the selectively permeable cell membrane, they described its structure as a fluid mosaic. You might know that a mosaic is a picture made up of little tiles. Like a mosaic, the cell membrane is made up of different parts as well. The cell membrane has 2 layers of phospholipids, referred to as a lipid bilayer. The lipid bilayer isn't rigid. The phospholipids in it have the ability to move in a flexible, wave-like motion. Let's take a closer look at a few phospholipids. The round head portions are hydrophilic, which means they are attracted to water. Both the extracellular fluid, meaning fluid outside the cell, and the cytoplasm inside the cell are mostly made up of water. So the hydrophilic phospholipid heads of the outer layer will be oriented toward the extracellular fluid, and the heads of the inner layer will be oriented toward the cytoplasm. The phospholipid tails are hydrophobic, which means watery areas repel them, so they orient toward each other in a direction as far away from the watery content as possible. There are also scattered proteins embedded in the phospholipid layers.
And one other thing to notice that they didn't mention here is that these proteins can be tunnels. And so there's like a little hole in that protein right there. And they can be tunnels that let things through like water. Okay, here's a nice side view of those tunnels, or they also call them channels, which I don't think the word channel is as commonly used as the word tunnel, so I like to use the word tunnel. But you can see molecules go through them. They can go into the cell through them or come out of the cell through them. And you can even move lots of things quickly in and out of the cell through these things. Okay, so here we are with our little animal cell, and we've got a little box we're zooming into. And behold, here it is. So what we see is the cell membrane is a phospholipid bilayer. That's a mouthful. Now, the blue stuff is the cytoplasm of the cell. So we're going to write cytoplasm. Out here is outside the cell. Now, the main thing that makes up the cell membrane, or the phospholipid bilayer, is one of these guys, and he is called a phospholipid. Okay, the word lipid means fat, and the phospho comes from the fact that he has a phosphate up here. That makes him hydrophilic. The phosphate makes him hydrophilic. So remember that hydrophilic means that it loves water, but the bottom of the phospholipid is hydrophobic. Remember that hydrophobic means it's afraid of water. So we come up here and look at the way it arranges itself. It's called a bilayer. That means 2 layers. So these things stay together in 2 layers because the middle is hydrophobic or non-polar. It doesn't like water. Now I'm going to write the word non-polar in here. Remember that the word nonpolar means the same thing as hydrophobic. So what happens is the inside of this thing is like a force field that doesn't like water. So any water in the cell can't get out, and any water outside the cell can't get in. I'm going to draw a water molecule. I'm going to draw it bouncing off. Same thing for salt. If you have a piece of salt out here, like sodium, it's going to come and it's going to bounce off. So it's like a force field in both directions. Things just bounce off. They can't move through it. But at the same time, on the outside, it's polar, and so it likes water on the outside, but it hates water on the inside. All right, let's describe this with some words. The flexible layer that surrounds outside of every cell, it's called the membrane. Okay. Another name given to the cell membrane that describes the fact that it's two sides that are identical but flipped. It's a phospholipid bilayer. That's a lot of words. That's a mouthful. Now, let's get back to this mosaic idea. The weird name for how you should think of a cell membrane. It's called the fluid mosaic model. So it's a mosaic because it's made up of a million little molecules and they're fluid. They can bend and move. And that's why when you push on your cells, they're squishy and they don't just hold firm, but they adjust to pressure, and not even the whole cell. Like just one little part of the cell can bend and move. It's a very fluid thing. It's made out of 1,000 little pieces. I gotta tell you about my trip to Israel. I've never told you about this before, but I actually, just a few years ago, had the privilege of flying all the way to Israel from Oregon. And I went on like a 10 or 12-day trip to Israel and got to see a lot of the places where Jesus actually walked. And one of them is a church with a mosaic on the floor. So when I heard the word mosaic in this video, I thought, I remember a mosaic I took pictures of. All right, this is called the Earth. Maybe you're familiar with it. And I don't know which part of the Earth you're currently occupying, but I'm in like this part right here. Probably right about there. But I got to get on an airplane one time and fly all the way over there. And the place I flew to is called Israel. And so let's just let the Earth go there right now by hitting the search button. Okay, and so Israel is right here. It has some borders. It's kind of hard to see the borders on this map, so I'm just going to take them away anyways. But if we zoom out a little bit, this big blue thing right here is called the Mediterranean Sea. And basically the whole Bible is about the area around the Mediterranean Sea. But the guy Jesus, who I kind of like to call myself after, Christian, I'm one of those, a follower of Christ. Christian literally means little Christ. He hung out in this country right here called Israel. And specifically right around this big lake right here called the Sea of Galilee. It's not really a sea, it's just a big lake, but they called it the Sea of Galilee. And there's a little tiny church. This is just one of the many places we visited. In his day, they didn't call it a church, they called it a synagogue. And I'm not going to be able to find it perfectly here. So I'm going to type in Magdala, and I don't know what's going to come up. There we go. And I think I recognize it. There's a big church there now. That's this. So this is the big church that's there called the Magdala Chapel. But over here, they're excavating. And maybe they're done excavating. I think it's this right here. It says synagogue right here. I don't even know if you can see everything I'm looking at. But I have pictures from my time there. And so this is all excavated. And then they built a roof over this portion right here that they excavated. All right, so this is it. I was there 2022, I think. Now this road right here, that's kind of hard to see probably. This would have been a first century road in Jesus' time that Jesus probably would have walked on. And all those other stones you see are like the footings of buildings, like the base of buildings. And what happens over time, especially when like around 70 AD, there was this thing called the War of the Jews, and the Romans came and just destroyed like every city. And so basically everything gets destroyed and kind of buried. And then when people come back and resettle, if they do that, they build on top of the ruins. And so everything just stays underground for like the rest of time. And so people can come back and then dig it out and look at it. And so that's what we're looking at here, is what's called first century, when Jesus lived. These are first century ruins that have been uncovered. Now I'm getting to the mural. This is a picture of the road. This is the first century road Jesus would have walked on. And then this is what their churches looked like back then. They're called synagogues. That's what a Jewish church is called. And so this is a reenactment, like has an actor in there that's dressed like someone from the first century. This is another place we were at a different time. And you can see how there's like a pulpit in the center there. And this is the part they built a roof over because it's so special. Because this was their church. This was their synagogue where Jesus would have come inside and taught, because Jesus was a traveling preacher. And then there's some mosaics on the floor up ahead. And so I come and I walked over and I took some pictures of this stuff. And you can actually see the mosaics on the floor still. And so this is a mosaic. It's where you take a bunch of little pieces of tile or rock and you put them together and you just make something that kind of looks like a picture or a thing. So what's amazing about this mosaic is that it's a mosaic that the feet of Jesus probably walked on. And it's from the first century when Jesus was alive. And it's just cool, like this is a broken down old first century synagogue that Jesus probably would have taught in and spoke in when he was alive on the earth. Now, I hope to someday actually teach classes about God and not just classes about science, and I'll probably get to draw from my experiences of having visited Israel and seen like every place in Israel. But anyway, that's just a little taste of some things I've learned. Back to the science. All right, so I thought of this toy while I was explaining a mosaic to you. Maybe you've played with one of these, although this one would be a little bigger than you've ever seen. You push something up against it, only some of the pieces move. This would be like the cell membrane if you could push your whole body against it. Okay, this is going to be cuteness overload, cute little baby face in the pin art toy. Oh, there's a dad with glasses, kiss from a little girl. Okay, you get the idea. So this is how the cell membrane is. It's a fluid mosaic model. Maybe that makes sense to you now. Now, the main piece by number of the cell membrane, look at it. Which thing is most of it? The blue and yellow pieces, which are called phospholipids. Phospholipids. But there is a second piece in there. This guy, his name is cholesterol. I'm hoping your common sense just went off. Cholesterol? That doesn't sound right. Cholesterol. When I was a boy, my dad had high cholesterol, so we were always eating chicken and pork.
Rinse and repeat.
It was a hard childhood. Man, I still have trauma deep down. Okay, because I didn't get enough red meat. Red meat has lots of cholesterol. Delicious. Steak, hamburgers, ground beef, America! Cholesterol are these orange molecules in here, and they are actually steroids. A steroid piece that adds strength to the animal cell membranes and makes up 10 to 30% of them. So today, people are less concerned about cholesterol than they were in the 90s, back when dinosaurs roamed the earth. But there is a thing in here, right about here, called your liver. And they've discovered that some people, their liver doesn't sense how much cholesterol is in there the way it should. And so as they age, their cholesterol levels are high all the time. And because cholesterol adds strength to a cell membrane, if you have too much cholesterol floating around in your bloodstream all the time, your arteries will become too strong. They'll become stenotic. They'll become stiff. And then you're likely to have a blood clot form in there, or a clot of fat. And it can cause, if you have that in your brain, it can cause a stroke or an aneurysm. And if it happens in your heart, it can cause a heart attack. And so these are dangerous things. But they've came out with amazing drugs. One of them is called Lipitor for lipids, which is a big word for fat. And so you can try diet and exercise all the way. You can try just not eating any cholesterol, but it's kind of hard to get your body to lower your cholesterol when your body's like, but I want to turn up my cholesterol. And so genetically, some people are predisposed to have higher levels of cholesterol no matter what they do. And that was my dad's story.
So unfair.
He tried so hard to have low cholesterol, and it was at like 200 or something, no matter what he did. And then he takes this drug called Lipitor, and like overnight, his cholesterols go down to 100 or something like that. And so the liver is like a thermostat for how much fat is in your blood. It can play a big role in whether things are working right or not. Okay, looks like we've got one more word here. The name of the fluid on the inside of the cell. We've already labeled that beautiful blue stuff. It's called cytoplasm. And the nature of the top of a phospholipid, hydrophilic. And the nature of the bottom of the phospholipid, hydrophobic. And that brings us to the purpose of the cell membrane. What is that thing for? And now I get to talk about the greatest soccer player of all time. Let's watch him play soccer for a minute. Boom. Oh, look at that. Oh, unbelievable. Magic.
My word, Rob, what a goal that is.
What a goal. Oh, yeah.
He is out of this world.
Out of this world. Here we go. Boop.
Messi's free kick.
Oh, beautiful.
That is world class.
That is world class. Now, some of you may have a different opinion out there. Okay, you might be thinking about that other guy, Raffaldo, Rafflingo. I don't even know his name. But the reason Messi is the greatest of all time, the GOAT, it's not because of his free kicks, although he takes great free kicks. It's because of the way he moves with the ball.
Assistència de Xavi, més capradeta per Messi, Messi, immens Messi, encara 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 Messi, gol, 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 gol.
Go, 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 go! Let's see how many guys he beats. 1, 2, 3, 4, 5, 6, 7. He's just special. He's just a special little man. Now, many of you may love the game of football, which really ought to be called hand egg. Soccer, which ought to be called football, is actually the greatest game. And Messi is the greatest player.
Fight me.
I may lose some subscribers over this. So be it.
Fight me.
The reason I'm talking about this, permeability. Let's talk about a soccer net. A soccer net is semi-permeable. To be permeable is to let things through. To be impermeable is to not let anything through. And to be semi-permeable, which is what the cell membrane needs to be, is to let some things through. A soccer net is semi-permeable. There are people sitting behind the soccer net. They need the light to bounce off the players and the ball in the field and to come through the net. The wind needs to be able to travel through the net. If it's raining, the rain needs to go through the net. Little tiny bugs travel through the net. The net is permeable to lots of little things. But there is one thing we want the net to be impermeable to, and that is the soccer ball. The whole point of the net is to catch the ball, so we all know the ball went through the goal and it stopped at the net. In the same way, cells have to control what goes in and out. And so cells have been designed to be selectively permeable, to let some things in and to let some things out. A couple more words to write down. The main purpose of the cell membrane is to be a barrier, and specifically to be a barrier that only lets some things through, and the word for that is to be semi-permeable. Specifically, to be impermeable to certain things, while being permeable to others. In the next lesson, you're going to learn more about what is and isn't supposed to come through the cell. All right, that brings us back to the big question. God designed cell membranes to keep out danger. How is this like the way your parents set boundaries to protect you? I started teaching when I was 23. I was closer in age to the high schoolers than to their parents. And I remember watching kids have real problems with their parents. And I remember being kind of surprised by that because my parents were actually probably too permissive. And so I remember kids having issues with their parents, good kids, Christian kids. I was doing youth ministry while I was a teacher. And I remember seeing like Christian kids resenting their parents. And I remember being like, what? Not really understanding that because I didn't grow up as a Christian. And so I didn't really understand the dynamic of like having good Christian parents and being a kid growing up and boundaries and parents being strict and stuff like that. My parents were not as strict on me, and I was the youngest kid, and I'd watch my older brothers get in a lot of trouble, and I was pretty easy on my parents. And it's hard as a kid to have your parents setting boundaries that you don't really understand. I now have a college kid, and I have 2 kids in high school, and I have a kid in middle school, and I have a kid in 5th grade. And I can tell you, parents want what is best for their kids, and they put barriers in place to protect their kids. And if anybody doesn't have a very good understanding of what's going on, it's the kids, not the parents. Parents have been around a long time. They see the big picture a lot better than kids do. And kids do not see the big picture yet. So in the same way that God designed the cell and he put some boundaries around it to keep it safe and protected, your parents are looking at your life and they're looking at the outside world and they're saying, we're going to put this boundary in place and we're going to put that boundary in place. And they are not doing this because they don't love you. They are not doing this because they want bad things for you. Exactly the opposite. But kids always think their parents are like out to get them and they want to ruin their lives. You could not be more wrong about that. Your parents want good things for you, which is why they are putting barriers in place. And so as a person, as a third party here, not directly involved, I don't even know your name. Your parents, what they're doing, it's for your good. And the Bible says that a father disciplines a child he loves. Now, I'm not even talking about discipline. I'm just talking about parents setting up some boundaries to keep you safe. More boundaries is more better for you, okay? So thank your parents for the boundaries they're putting in your life. You're going to turn out better. The only kids that I see who are messed up are the kids whose parents haven't put enough boundaries on their life. Thank your parents for everything they're doing for you. It is for your good. I hope I made this interesting for you. Have a great day. Peace out, Girl Scouts.